student or graduate who works in an industry to gain experience. That's the noun form of the verb, of the word, pardon me. The verb form of the word is to imprison. So I'm just glad to know that both sides of the form of the word is very true here. I'm only kidding though. So just to kind of talk a little bit about the internship program and how it works here, and then to have these guys kind of show their talents and what they've been able to accomplish in their short time here. We just started doing the internship program probably about 3 years ago. And prior to that, I almost consider Jim our initial inaugural intern, because at the ripe old age of 22, he ended up in my office one day, and that was the beginning of our long lasting work relationship. And again, coming out of school, didn't have a ton of experience, and has worked his way up into a very high level and very valuable role here at CADimensions. So thank you, Jim. Thank you.
And Sarah learned a lot about cars along the way.
I did. I can tell the sound of a Subaru versus a Honda versus a Toyota versus a Lexus, and I'm very proud to say that Jim taught me all of that. So, shameless plug for the Seattle Seahawk Super Bowl winning trophy mug. After that, we started to look into co-op programs, and we did hire a co-op out of RIT, and he actually joined us for a couple of years as a full-time employee as well. And it worked out pretty well, but due to the nature of the business, we didn't really focus on it too much until maybe about a year later. And I work part-time at RIT sometimes, teaching some classes there, and Gary McHugh, who's my boss, and Pete DeLore, also my boss, said, do you have any young people there who would like to work here? There's kind of an internship-based employment, and we're like, yeah, let's try it. So brought a couple of them in. It worked out pretty well, and then we decided to continue on with it. We still work with RIT, and then Gary got in touch with John Waddick over at Monroe Community College, and that's how we ended up with these two fine young men, Derek and John, and also Katie as well. Obviously, they once they finish up with their time here at MCC, they do plan to go on to bigger and better things. I believe RIT and Syracuse University are the destinations that are going to be coming, and actually that's I think partly where Katie is today, not the Today Show. So that's pretty much what the internship program is. They definitely help us out, and hopefully we give them a good experience, a good background to help them with their education and in the future. The thing that I find most beneficial is the youthfulness, because they teach me things that I would probably not be in touch with anymore, and I have a great time quizzing Derek on movies from the 90s. So
never get out of it.
That's definitely the fun part.
And just so if you haven't done the math, Derek was born in the 90s, which was the highlight of my adulthood. But anyhow, I'm going to turn this over to Jim and just have him talk to these guys about what they're doing and go from there.
Yeah, so what we have up here on the screen is just kind of a quick rundown of the topics that we want to talk about. One of the things that we do with our interns is give them a kind of a little project. Sarah's famous for going to Walmart and picking up some Legos, and we come back and kind of have them take it apart, measure it up, draw all the stuff in SolidWorks. And this time around, we had them take and animate the assemblies of them. So that's something Derek's going to talk about with the animation versus the composer or motion. John went a little bit crazy with equations because he likes math and Excel and equations. So he did some pretty neat things with using a text file to help drive his Lego equations, and along the way learned a couple of cool tricks that we thought we'd share with you. And then the configuration publisher is kind of a given for the Legos, right? They're all pretty similar, just different lengths and widths. So what we're going to talk about here today is going to be those three things, and then the last one, the Project Mav, is kind of a surprise. In John's time here, he got access to some really cool products and programs that we sell here, and kind of spark some neat ideas that I think you'll all like. So I'm going to turn it over to John for the text-based equation stuff here, and we'll see if he can shock you guys like he did us.
Great. Thanks, Jim.
You presented it first.
Okay.
I'm still half asleep. There we go. There's John.
Fun with math.
All right. Fun with math.
So as Jim suggested there, coming in and being an intern, for me, being a slightly non-traditional intern in that I have some professional experience and I'm a non-traditional student as well, but what this does for me is I really appreciate the flexibility of being an intern, working with school and all the other things going on, as well as coming in and being able to learn SolidWorks from the experts here. And this particular project I thought was very useful use of SolidWorks and how it might actually be used in industry. Taking a set of Lego parts, which, as Jim suggested, are all pretty similar. There really is a design formula behind them, and even though they're shaped differently and come in all different sizes, there really is a foundation of all of the parts. And I think if anyone who's ever been in any of our training classes, we like to hound on the idea of design intent. Very important. And when we were given this project, I kind of looked at it and said, okay, well, what am I going to do? I have almost 100 parts to model. How can I do this efficiently? And that got me thinking of what's the best approach in having this many parts and wanting to kind of find the underlying formula, which was kind of fun in itself. And obviously there's lots of information online, and that was very helpful as well. But being able to have the parts in hand and physically be touching them and having to put them into the SolidWorks was a fun challenge. And in looking at how I wanted to design these parts and make things as easy as possible on me moving forward, was looking at how to utilize design tables, and I wanted to utilize equations and configurations and how all these things play together as they would in any company that has multiple parts that are kind of similar but not all the same, and how you create a foundation for your models and your parts. So that got me mainly messing with design tables. So I thought, well, let's start with design tables. Let's see how I can quickly create configurations from kind of a single model and see how far that would get me. So when I was done, just to let you know, I ended up modeling 29 separate parts, and the particular model that I had was almost 100 parts, but they were all very similar, and I could take advantage of that. So in looking at what are the key elements to designing one particular part, there obviously is a formula, right? There's a formula to how big the little holes are, how wide is each Lego, how thick is each Lego, how the holes underneath are patterned and the text is patterned. So there really was a lot to this, and this kind of led me down the road of using equations and using a design table. And I found that in working with the design table, I couldn't get the exact interaction that I wanted with the equations alone or the design table alone, and then found integrating those two to be kind of unique. I had never done that before. I've worked with both individually, but when putting them together, I found that there was some interesting interaction in how I could control the equations from the design table. And I found it was very useful to the idea of wanting to link all equations from all of my different parts. And I didn't know how to do that. And it wasn't entirely clear to me, so I started digging into, okay, how can I use equations? How can I make this consistent? If I have to model almost 100 parts, I need some consistency throughout the entire batch. So that led me down this road of using a text file to link to my equations. And I thought this was very neat. It was very useful, and it allowed me to really create some consistency throughout all of my different parts, not only within a single part, but within an array of parts. So within my 29 parts, they're all governed by the exact same equations. And I'll show you how I did that here. So anyone who's used equations is used to this interface here where we have our global variables and features and equations. So you'll notice here this little import-export tabs here, and up until this point I had never used those, never had any need to use that. And looking in deeper and realizing that I could link my equations, as you see here, they're all linked, back to a text file. So I could create one text file, import that into each part, and have control over every single equation in every single part from one location. And that's where this came in. And you can see how simple the syntax is to creating these equations. So even right within the text file, I could add new equations. I can change the values here, and they will update in each part that I have linked this text file to. So you can see how nice this would be to go back to and have one location to be able to change these. And you can see here, I can even link those to other variables within the subset here. So I thought this was very neat. You could have done something similar to this, obviously, within Excel, within the design tables, which Excel has its own unique options and capabilities as well. But I thought this was very neat, being able to use a text file, have all my parts reference these variables. I could go in here and change these very easily, and every single one would update. And this really allowed me to control each part very specifically and create consistency throughout the entire model.
How bad was the back, like setting it up, John? Would you say?
I'd say it was very easy. I mean, the learning part, just kind of figuring out and determining how I wanted to approach it, I think took a little bit of time. But once I realized this was an option for me, it went very smoothly and very quickly. And like I said, you can see how easy and simple the syntax is here for doing that. And once I had this controlled, once I had my model controlled, I zipped through the parts. I mean, it was very easy. Once I spent the time up front to determine and control how I was going to model these parts, it went very quickly. And even setting this up was very easy. So I thought that was extremely useful, especially for anybody who has to control an array of parts and having some consistency in those parts. So this really is the control document for all 29 of my parts here.
That's great.
And I can change this very quickly.
So where do you keep that on your computer? You might want to change a couple
Yeah.
numbers.
So John, what happens if, say, somebody they build all these global variables right inside of SolidWorks, but then want to take all those and bring them out? Can they export those into a text file and then modify that in any way and then bring it back into another file so that you don't have to start in Notepad?
Absolutely. So you can see here, right when you go to export, that's the default file type is txt. So that is the underlining file for those variables. So that makes it very useful too. If you started with one part, you've created all your variables, you've gone through the process of labeling and naming, and you can export that right out, and then your next part you can import those right in. So that makes things very very nice and very efficient. Thanks. So I think that's it.
More about equations than I want to know.
Yeah.
Told you guys he liked math.
Can we take a look at the finished assembly again, Jeff?
Oh, sure. Sure.
Very, very neat.
He sat over in his corner with a pair of calipers for like a week, just measuring things. And
it definitely took some time getting used to. Once I got on a roll of taking this physical model and putting it into SolidWorks, that in itself was a nice lesson as well.
Wasn't it on the Lego website? Like they talked about their tolerances and things like that.
Yep. There were resources about how they chose their thickness and their distances and the size of the little cylinder here and a lot of things, and to the level of control that I had on each part made the assembly very, very easy to do. You can imagine if there were some differences between parts and you're trying to line these things up and create mates, it would have been a nightmare had they not been so controlled, and tolerances all the same. So that actually made it very simple, and I didn't have any mates blow up on me. So you can see here the feature tree is kind of long, so it was important that they were all within the same tolerances and governed by the same values.
The beauty about doing this in SolidWorks too is like when you build these on your own. If you're me, I always have like a little hammer and a bottle of glue as well. just to make sure they fit together.
That's
So
right.
doing this in SolidWorks, everything seems to fit
Everything
together.
fits
I'm gonna
together.
smash it afterwards and then put it back together.
Oh, just a little tap. Just a little tap. All right, trivia time. Ready? Lego trivia. What do Legos and our very own Lars Christensen have in common?
Danish.
Say again?
They're both Danish.
Thank you. They are both created in Denmark.
Yes.
All right. No prizes available, so. But just a little Lego trivia.
Your prizes you get to buy lunch.
Ah.
All right, well, thank you, John.
Yeah, let's take a look at what Derek has to show about the configuration publisher here. Let's switch over to him. And it's going to kind of be a continuation of what John talked about with the Lego project, but I think it's a good theme, seeing as how there's a lot of ways, especially if you're in the business of making similar parts. So.
All right, thank you. Actually, the configuration publisher was something I stumbled across maybe a month and a half, 2 months ago. I was actually working a case with a customer, and he had a couple questions about the configuration publisher, and it was not something I really had any idea of what it even did. So once I started digging into it, it actually became something that I thought would be very helpful, especially in this case alone, was that the fact that when you bring in a part into a assembly, instead of having to specify which configuration you wanted, it would ask you for variations or parameters about that file, and then it would pick the specified configuration for you. So if you have a ton of different configurations and they're all just part numbers, they have absolutely no description to them at all of what it actually is, you can go in and say, I want us to ask us about the diameter and the length, and then it would say, okay, what diameter do you want? You pick 8 or 6 or whatever, and then you could pick the length associated with that, and it would automatically pick the configuration. So if you had a whole bunch of just part numbers in there that you didn't know exactly what size they were, I thought it would be very helpful. And in this case, you can see that I have a whole bunch of different configurations. I have 1x4, 1x6, 1x8. In this case, I have those numbered so they match what we're doing here pretty easily. But in a sense where if they were all different part numbers, it would be a little bit harder to tell. So the configuration publisher can be opened up right through a right click here. You can see configuration publisher. So what happens here is that it actually brings up your design table that you have because it looks at what's in your design table. If you don't have those parameters in your design table, you won't be able to see those in your configuration publisher. So that's just a key fact. Make sure that they're in there. So now it's saying, okay, what do we want to put in here for our parameters? What do we want it to ask us when we bring it in? So in this case, I have these patterns, so it's just a length and a width. So in this case, I just want to say how long is it and how wide is it? So I have a couple things here. So I have my, I think it's linear pattern 2. This is the length, so I'm just going to change the name to length. And my last pattern here is the width. And I'm going to change this to just width. So what's going to happen is when I bring this into an assembly, just this part, it's going to prompt me to say, what's the length do you want and what's the width do you want, and it'll pick the specified configuration for that. So we're just going to go ahead and hit apply, and we can close this down. And then we'll just save this off, rebuild and save. You always want to save your files. And so we're just going to start a new assembly. And I'm just going to pick on the document that I want. I don't even have to specify a configuration. I don't have to make sure I'm in the correct configuration. I'm just going to go ahead and hit OK. And you can see right here it says configure component. And it's telling me what are the parameters we want to select. So in this case, I may want my length to be 6, and then it'll appropriate which width we would like. So we say 1, 2, or 3. In this case, I'll just pick 2. And once we've done that, we can go ahead and hit OK. And we have our 2x6 Lego block. So in this case, I think it's really, really helpful if you have just a whole bunch of list of part numbers or even just a lot of them to look. Having parameters to specify is a lot helpful. And in this case, it is very basic, very simple. The customer that we were working with was doing bearings, like how big was the bearing and how many bearings were in it and all that. And all of those, in his case, were all part numbers. And he had about 150 configurations to one part. So it was very useful to him.
Oh, that's great.
Yeah, so every time he would drag it in, you get to choose from that nice long list. Just kind of breaks it up a little bit. It's like searching it. That's pretty sweet. I forget about all these cool things in SolidWorks because there's just so much.
And that kind of moves along too with, like Derek said, he was working with a case with a customer, and with our internship program, we do give them projects like this, like the Lego projects and some other ones, but they are working members of our group as well. So they do take tech support cases, they are involved in training, they are involved with seminars. Pretty much the only difference between them and us is they're still going to school and at night and during the day, and we go home and lay on the couch. That's about it. Maybe a little bit more. But again, so you will be, I'm sure if you haven't already, you probably talked to Derek or John. And the other thing too with Derek, I didn't mention it earlier, is we have had him since he was pretty much a freshman in college. So his first semester at MCC is when we got Derek, and I hope we get to keep him all through his bachelor's degree and beyond. He never caught on to the little ankle bracelet I put on him a couple of months ago. The tracking, and I'm also working on John by trying to butter him up too, but we'll see what happens.
John's from the South, so he sometimes doesn't like the New York weather, and I can't blame him.
So like right now he's good.
Yeah.
January it was
sunshine.
Yeah, January was a little different, kind of little Edward Cullen kind of thing going on. Pop culture. All right.
Sorry, even I didn't get that.
Oh, diamonds are forever. Okay, thank you, Derek.
I think I'm going to talk about the differences between Composer and Motion now.
Yes.
When we were doing in this, or starting in this, Franco would advise us to make an animation of how this thing basically came together.
We should rephrase that. Franco sent you a really awesome video of the coolest animation of Legos going together and said, I want you guys to make this.
And they made it cooler.
And yeah. So I think Derek's got some pretty neat tips and tricks with that. So we didn't tell them how to do it. We didn't say you have to use SolidWorks or you have to use Composer. We kind of just let them run with it and struggle a little bit, so to say. And I think I saw Derek running around hitting things. But anyway, in the end, they came with some really cool animations. So he wants to kind of share some of that information with you guys.
So yeah, animations in SolidWorks are just like they are in Composer. You can do pretty much the same things with exploding them, collapsing them, but when you start digging into a little bit more, like if you wanted to do instructions of how this Lego came together, that's where you'd start moving into Composer. When you started doing it inside of SolidWorks, everything is possible. You can do it fairly easily, but Composer is just a little bit easier, and sometimes a little bit faster. And it's just, I think it's a little bit easier. And then once you're in there, you can kind of see all the cool stuff that it can do that you want to do a little bit more. Where John, I mean, when he was doing his project that he's going to talk about a little bit, you'll see once he started digging into Composer, all of the really neat things that he came up with just absolutely blew my mind. So I think that's about it. Just talking about its ease of use for Composer.
It has a lot of different functions that you don't get with SolidWorks. You know, being a solid modeler and Composer being an actual publishing tool, you get a lot more flexibility, especially with like Derek said, assembly instructions. And I can't prove it, but I think that it looks almost like Legos do use like Composer for their assembly instructions. Yeah, there's a little copyright on there, but there is some key differences. But I think they both learned a lot about Composer and the value that it has. In conjunction with SolidWorks. So
I also
have your project in Composer, right?
I do, and that started with the Legos as well. I mean, as we were kind of looking at how to make this animation, how to control a large number of parts, and kind of do them in a unique way. And obviously, SolidWorks Motion is capable of doing that, but we found Composer to be very nicely suited for that application.
We made them like assembly one piece at a time and animated, so you can imagine there was 100 or so parts, and having those come together kind of one piece at a time and then into a larger assembly.
Mm-hmm. Another thing I suggested for the next internship program was just take the Legos that we had, and I mean, when everybody gets Legos, they always kind of tear it apart and kind of modify it their own specific way. So I thought maybe the next interns we have them build an assembly instructions like the Lego flip book that you get for their own specific variation of that specific Lego, and that you just can't do inside SolidWorks. That's something that you would have to use Composer for.
Need that publishing tool? Do something to demonstrate it.
Yeah, I do as well. If you want to, make me present, I'll show you the Lego project.
Because that was the cool part.
And good. Okay. So here's the Composer interface, and you'll notice the timeline here. This is the animation interface. It's somewhat similar to what you've seen in SolidWorks, but a slightly different approach. And I think that approach kind of helps the ease of working specifically with animations.
Keyframes, John.
It is a lot of keyframes. Yes, and I'll just show you here how this looks within the interface, and obviously you can export this into an AVI or whatever media you might be working with. So here's kind of one approach that I took to taking the finished assembly, loading it into Composer, and then working with each part within Composer. And
yeah, it's a little jumpy.
It plays a lot smoother, just the web meeting's not.
And just to give you an idea of how these pieces come together. And once I went through, made each keyframe for each part, I could then copy and paste, and I can take this, I can elongate each space between frames, I can slow it down. So you can see it's some very cool things and you can do very quickly in SolidWorks or in Composer, whereas SolidWorks might have taken a little more time. You would have access to simulation and some physics engines within Motion, but Composer really is just a visual, kind of technical manual representation tool. So
one thing that I noticed about your Composer, John, was you took basically sub-assemblies off when you were taking them and brought them over into their own thing and then exploded those. I know in SolidWorks it's I think a little bit trickier to do than just the standard.
A little bit, yeah, and it's very, I would say, the animation is much lighter in Composer than necessarily in SolidWorks, just because of everything else that's going on within within the program, and it's maintaining the model and all of those features that go along with the model itself. And this is a very light representation of the assembly, and that allows you to do things a little quickly and a little easier. So I found that very useful.
And I appreciate you guys taking the time to do that, because we do get that question quite a bit. You know, if we have Motion or the Motion animation tool in SolidWorks, what do we need Composer for? And I think that's a great representation of what the key differences are. And like John said, especially the physics engines in the SolidWorks Motion. Again, this is a great publishing tool, a great presentation tool. SolidWorks is more based on the mathematics and the physics and the science behind it.
Yeah.
I think when John moves over into his project that he's going to be talking about, you'll see some other really, really cool things that you can do with Composer that you cannot do with SolidWorks, especially with PowerPoint presentations, which we all use.
Yeah.
We'll kind of lead into that, a little bit of a backstory before we get to John's project. A few years ago, oh gosh, was it now 3 years ago, at SolidWorks World in Orlando, roughly around there, 2-3 years ago. We were at one of the main presentations, and Jim can give better details than I'm about to give. But a professor from one of the major universities came out and showed what his students were doing with drones, and we're like, drones? What's that? And out came these 4-propeller flying machines. Now, we'd already been dabbling with helicopters here quite a bit, maybe too much. And it's like, what? We only have 1 blade. There's 4. Even better. So, and then they started showing what they were doing with them, and I'll let Jim kind of follow up with that. And that kind of started this whole 3-year project of quadcopters.
Yeah, so the professor was B.J. Kumar. He did about an hour-long presentation about the power of the quadcopters that they were working with the schools. Pretty amazing what they can do with them. They were more autonomous, had kind of a camera that would know its position, and it would do things like go on a figure 8 and not hit each other. They could make them go through a window. It would calculate the arc to turn sideways to fit through an area.
Play musical instruments.
Play musical instruments. There is a video on YouTube of the BJ's quadcopters playing James Bond theme.
Yeah.
And so that kind of I've always been into RC stuff, and I was like, man, I'd like to fly some stuff, but I've tried airplanes, and I just crashed them really bad. It got expensive. I just said no. So when those little Air Hogs $20 helicopter things came out from Walmart, I ended up kind of getting a couple of those, and they were fun, but just lacked the control. And if any of you have seen our blog, which I need to update, we did kind of start a project where we wanted to build a 3D printed, larger quadcopter for CADimensions, kind of team to build. And I wanted to build one, and then I started talking to Franco and Derek and John, and it was like, oh, everybody wanted to get involved. So that became a much larger project, and be on the lookout for that soon. There should be some more updates on the CADimensions blog about that, which hopefully everybody's reading. So when John came, he thought it was really, really neat, and he had a project to do for school, which was, what was your project, baseball robot or
That
something?
was the RC car.
The original, the base project.
Yeah.
Yeah, it was a vehicle following the line and avoiding obstacles. That was the original.
That wasn't cool enough for John, so he wanted to take it a step further, and I'll turn it over to him so he can kind of talk about his project a little bit, kind of what he decided to do based on the quadcopter that we're building here.
Yeah, thanks, Jim. That I before coming here, I had some introduction to quadcopters and drones, and just enough to be interested in it, and kind of knew I wanted to. I would have liked to have built one, and that was mostly a pipe dream until I came here and saw what the guys and Jim were actually putting together, and that honestly it inspired me, and it made me realize that it is possible, and seeing what they were doing in SolidWorks and how they were actually building this thing was very inspiring. So that was correlated very nicely to me starting this past semester, the spring semester, and having the opportunity to choose a project that I wanted to do, and seeing that, knowing it was feasible, that's what I went for. So I decided I wanted to build an autonomous quadcopter, much in the same likeness as what Jim's CADcopter is, and as you'll be seeing some of those materials and what he's done, it's very impressive as well. So that was an inspiration to me, and I think there's no better way to learn SolidWorks than to apply it to something you care about. Just the amount of motivation and discipline that I was able to put into learning SolidWorks tools like Composer was extremely helped by the idea of just wanting to do this and wanting so much to have it look really good and look right, and digging into it and wanting it to be exactly the way I wanted it. It was a great platform.
You used a lot of the suite too, because I saw you working with routing.
Working with routing, absolutely. Absolutely, yeah. I got a couple funny looks from looking into the book, but starting with the book and then having to apply it to something that I needed was great practice. It was really helpful. So I would recommend that to anyone if you have a personal project, and you can apply any of it in SolidWorks. It's a great tool for learning.
And like you said, as you were moving down through, so you started off with the CAD tool, got the solid modeling done. I can put the electronics here and went into routing, and then it's like I have to present this to my group, and then you got into Composer, and
absolutely, and it very much led from very much sequentially in that way. And this is the project. We've got our Project Maverick, and I just want to go through one or two slides of the PowerPoint. This was our final presentation, but really, to me, this kind of embodies all that SolidWorks allowed me to do and provided for me. Although I won't necessarily show you the model that I built, there it is. I mean, that is the model. What you see here is a render, a 3D render of my assembly, and this is the quadcopter that we built. I think Jim can attest to how closely it looks like that. I mean, it's remarkable how close I was able to get to it.
You even modeled up the zip ties.
Absolutely, the zip ties, the Velcro straps. I mean, once I got going, it became quite an obsession to get it exactly right. And not only was it a fun tool to kind of create what I was doing physically in this 3D environment, it was helpful. It was extremely helpful in designing, determining where things were going to be positioned within within our platform. We had limited space. It allowed me to find my center of mass and to locate parts very efficiently and effectively, as well as just see how this thing was going to piece together in general. And when I was looking at this, I had a table full of parts, and it was a little daunting at first, but once I started modeling, going through the process, being accurate with each part, knowing that my measurements were accurate, I knew I could take this into assembly and really make actual real-life decisions about how this thing was going to come together. So that was extremely useful. And like I said, this is our intro slide. This is a render. I even modeled the letters here as blocks, and it didn't start this way. It starts out very simple. Let me just get a render. Let me just do a PNG or a JPEG of the model, and it looks really cool. And then it's like, well, maybe I should put our names in there, and then, okay, well, it looks better if all the shadows are all together and it looks congruent. So it just, you can see how once you get into it and you begin to go further with it, kind of what could happen. So that was fun. And so out of the model, not only did I get was able to make intelligent design decisions, I was also able to make some really cool visual representations. And you know, in being able to sell a product, this would be critical. I mean, what people saw at the end of the day was this presentation. They didn't necessarily see the hard work and the pieces and the parts and the assembly that went into all this, but that this really is the culmination of that. And then in seeing this, that's what made the impression. So it was the hard work that went into it, but this was really the visual representation of my project, and that made it very powerful, I think. So even in the presentation, and this is in PowerPoint, by the way, and just a simple JPEG that I brought in. Moving on here, I was even able to make my PowerPoint template using Composer, and this was inspired by Jesse here, showing me what was possible and kind of coaching me in Composer as well. And you can see here, these are vector images that were exported from Composer. So once I had my assembly in SolidWorks, I could bring that into Composer and do some really neat visual things. So taking these illustrations out, making them solidly transparent and putting them in the background, and this piece as well is from Composer. So you can see how I really made, really tied the entire presentation together with SolidWorks tools. I mean, that was PowerPoint is really just the background. It's really the visual tools from SolidWorks that tied everything together very nicely. So I made my presentation template using Composer as well. So those tools were very interesting. And having these images as vector images as opposed to raster images, I get very nice control over the clarity and resolution of the image as well. So Composer has those nice export features, and you can really control how you export your media.
It looks nice. It's just a subtle background in there for the PowerPoint.
Yep, very subtle, but it adds a custom nature to it, and it's all very, very tied together and very congruent. And this was, I thought, one of the coolest parts of the presentation. So there's a nice feature with Composer. After working in Composer and kind of first initially just wanting to get some images out of it and do some interesting things, I learned that I could take my Composer model and embed it in PowerPoint and then manipulate it real time. Mm-hmm. And this was very cool. And thinking of a way of how do I introduce all these parts and all these pieces, this was a fantastic approach. And this is very unusual to see something able to move within a PowerPoint presentation. I think it was kind of refreshing to me to be able to have this type of control and allow for a dialogue between me and the audience, and be able to address and direct specific parts of the model, and even work through different views that it would move through real time. So some very cool things that I could do in Composer, and show each of the different components and utilizing the tool very effectively, I thought. So I thought this was a fantastic use of SolidWorks tools, and it really had its imprint across my entire project. So I thought it was very effective.
And just so you guys know, when John did do his presentation at MCC, they had a time limit, and he had so many questions. They had to tell him he needed to pack up his stuff and let people get in. And then when they finished, they asked him to come back in and set back up to finish out all the rest of the questions because he was just bombarded with all of this, the presentation that he had.
Yeah, the end of this project, or the result of this project, was they got some really cool aerial footage, and Jesse did a couple of pictures and stuff here for them, and they put it all together in a really nice video. But I don't know how well it's going to play on the meeting.
And we don't even have to play the whole thing, and you'll just see that SolidWorks even made it into our. There it is. That's the first image you see is the 3D render of the project. So it really was involved in every aspect of the entire process.
John, I believe this turned into an official club now too.
It did actually, yes. There was a lot of interest that came out of our project, and after we gave our presentation at Scholars Day, which is an annual event at MCC, there was so much excitement and interest in the project and in building these platforms that they've started a drone club at MCC. So hopefully, in showing them how these tools can be useful, that really gets the students involved in seeing how you use SolidWorks to actually create real physical systems and make real intelligent design decisions.
Some of those parts on that, the landing gear and the vibration mount for the flight controller are actually 3D printed from the machine at MCC, which John got to learn a little bit about how to tailor a part so that it can be printed for strength.
Yep.
Because you had a couple of iterations to those parts because they did essentially break, didn't they?
They did, and I was able to run stress analysis within SolidWorks on those particular parts and refine the location of material, and obviously better understand the weight to strength ratio that you really have to be considering, especially with anything that's going to be flying, right? I mean, weight is critical. So yes, I was able to design the legs, design the mounts that are here at the very top, and run stress analysis to know where the stress points would be within those parts and better refine the design. So those were custom parts and custom printed and performed very well once I kind of got in and did the right simulations and learned a lot about how they should be shaped and structured, and yeah, they worked well.
You forgot something in your rendering. You're missing a signature on the legs.
Oh yes, yep. That was probably the highlight of our project. We were able to spend some time with Dr. Neil deGrasse Tyson, who came and was the keynote speaker for the Scholars Day event, and me and my partner were asked to come and spend some time with him at a private donor reception that was done before his talk, and he signed our quad. So the legs will be staying with me the rest of the quadcopter when we're returning to MCC. So yeah, that's a personal item.
Needless to say, John and I have learned a lot about Arduino code because that's what these run on. Neither of us are programmers by any means, but there's enough information out there to make it simple, and it's a really, really neat thing. Like, he's got to turn this in, in a week?
Yes.
Got to give it back to MCC, so he's already itching to build his own because it gets addicting rather quickly. So if anybody out there enjoys this type of thing, feel free to give us a shout, and we'll be more than happy to talk to you. And
is there any place, John, where people can go see the full-length video?
Yes, there is a link. We can maybe send that out in some form or another. I actually
put it on the chat window. Do you have the link?
I do. I'll have to look it up. Yep. Yeah. And this is actually in PowerPoint as well, and embedded Vimeo video into that as well. And of course, I left the composer. Yeah, the composer template there too as well. So yes, this video is posted online, and I can actually get that link and send that out as well.
And it's worth a watch too. It would be nice to show up through the web meeting. It wouldn't do it justice, so you definitely want to take a look at it.
Yeah, maybe when we're sitting through Q&A, question and answer at the end, we can just play it. If you see some of it, it would.
Yep. And I'll find the link and make sure I get the right address.
Let me change the presenter back to you.
Okay.
So again, with the internship program, again, I hope you found what they're doing very interesting. And again, these are projects that they're doing, but also working with you folks, working with our customers. Not to put Derek but when he first joined us, I mean, he already had SolidWorks skills, but he didn't have a lot of industry experience. And by working with you, our customers, I mean, he's a surfacing master as far as I'm concerned. He's also been doing a ton with CamWorks, so just learning the machining aspect and sheet metal. I mean, he's just doing so much with sheet metal, so he's learned from this atmosphere, he's learned from our customers, and he's also taught us a lot of things. Same with John. Just yesterday, he and Jesse were working on guitar tuners, so I mean, it's just doing a fantastic job with it. So there's just so much that they can bring, and I know it's difficult for all industries, but I can't emphasize enough how beneficial it has been to us to have interns, to develop, to grow, and to become full-time portions of our team. So I just have a couple people who just walked in. The first one is Mr. Jesse Sprague. Jesse came from the University of Buffalo with a mechanical engineering degree. Oops, get behind.
Yeah.
As an intern, and we liked him so much. I call him my puppy project. A little story behind that. So Jesse was brought on as an intern, and it's kind of like when you're a kid and you bring a puppy home and your parents say no, but once you get it home, you kind of get used to it, and then they let you keep them. They let me keep them. So Jesse
on the carpet.
So he was one of the first interns that we had that we kept on full time, and then we had a product put forth to us, a new product called SolidWorks Electrical, and we're like, geez, you know, we have a lot of experience here, but we don't have a lot of electrical experience. So we brought in Ashley Cheney, who is from Clarkson University with an electrical engineering degree. And again, she may be the kitten project. I don't know. Jesse's a puppy. She's a kitten. We get to keep them. Once you bring them home, you can't take them back. So also up in our Syracuse office, we have Rich Lawrence, who couldn't be here today. He's from RIT. He's an industrial design graduate, and we brought him on full time as well. So the internship program really works for us, and I hopefully it works for these folks as well. We couldn't be more proud of them, and hope we continue on and get more in. And if you folks out there are looking for great workers, great talent, and a lot of fun, hire an intern.
Did you have the John just posted the link in the chat window.
He did organize it.
Yeah, so hopefully, I'm not sure how to
No, hang on, let me share it with everybody.
to pass that to everyone. Yeah, it seems I don't have that option, but at least there's the link for you.
There you go.
You know, watch back over here so you can play it.
If
while
you-
we're doing questions and answers.
Yeah, see if it plays through the thing. But if you guys have a second, it would definitely be worth a watch. It's what, a couple minutes long.
Yep, it's about 4 minutes.
Does have EDM, dubstep, some of that fancy young kid music nowadays, but it flows nice.
Yeah, Jeff,
They keep us
John's partner, Jeff, knows a professional videographer that they did send almost all of the video, the aerial photography that they had to him, and he, being a professional, put it all together. So it is a very well put together video.
We were very fortunate in that sense to have someone take the footage that we were able to get in and put it into a really nice package. And here's the link to, just in case. It's on Vimeo. So
yeah, if anybody has any questions, type them in the chat window. We'll see if we can help you, or if you want any more information about things we've talked about here, feel free to contact us. All of our contact information is on the CADimensions website. There is a contact page, and it has the information. But yeah, here's John's Team Top Gun.
Coos.
So that's his little vibration mount there that was printed.
and I believe there's a CADimensions is called out.
Yes.
I think there's CADimensions called out.
And as you can see, this
There
is
it
back
is.
when it was cold outside.
Yes.
Isn't it still? I think I was wearing a t-shirt that day. John was wearing a winter coat. But
Yeah, not a lot of green scenery to look at, unfortunately. But there's Katie. It's our other intern.
It's lagging.
That's a brief,
Is it?
a
Yeah.
brief cameo.
John did learn an important, well, John's partner learned an important lesson. They were testing the stability in the air because it does self-stabilize if you push it a little bit. He pushed it a little too hard, so it tilted towards himself and caught him in the back and cut through his jacket and left him with a nice
And we
gag.
decided to include all of our failures into the video as well, which
There are a few
a little bit of
crashes,
a
but
lag here.
Yeah, I think we're sucking up all our bandwidth here.
I remember at one point in the video it lands and you hear the battery warning flat or beeping at you because it's almost completely dead. Would have just fallen right
Yeah.
out of the sky.
Yeah, and we thought that was a key part of any design process is failure. So we thought it was important.
You didn't actually crash it hard enough to break any parts
Did not.
other than props.
That's
So
very lucky.
he got lucky there. He's still flying it. Maybe on lunchtime today we'll be able to get off and play with it a little bit. But
Before you have to go turn it back in.
That's true. So it looks like it's lagging a little bit, but certainly take that link and take the time to look at it. I'm very happy with how it turned out. So
excellent. If anybody has any questions, we'll hang here for a minute. But if not, everybody enjoy your Friday. It is looking like it's going to be a nice day, so hopefully you can sneak out a little bit early. We won't tell your bosses. Sarah, you didn't hear that.
I'll be right behind you.
You're driving the Cooper today.
That's right.
Top down.
That's right. That's the way it should be.
Excellent.
All right. Well, thank you. All right. Looks like we don't really have any questions, so we're going to go ahead and wrap this up. But like I said, if anybody has any additional questions later on, feel free to give us a call and speak with one of us. Have a great weekend. Everywhere.
thanks. Bye.